This video is designed to review week 4 material to help you get ready for your quiz today. One of the things you need to understand is the difference between dilation and similarity. A dilation is where you take an object and you either enlarge it, okay, and then this is your original figure, and I'll call this point like A, and then the enlargement would be A prime. So the new figure always has this little apostrophe on it. Or the figure could be a reduction. And if this is point B, again, this point down here would be B prime with the little apostrophe. Okay? Similarity is when you have two figures and they are the same shape but not the same size. Okay? And the reason they're similar is there's a scale factor. The scale factor we usually refer to as K. So if this is a 2 and this is, let's say this is a 6, well, the scale factor, do you see how it got larger? So it went from 2 to 6. So you're always going to put the new over the old. This is something I didn't say, I don't think, in the previous videos. When you set up you find the scale factor, so 6 is the new one because this is my original. And again, I could know my original because this point is A, and this point would be A prime over the old, and then that reduces to 3. So that's a scale factor of 3. One thing that you need to see is that when the dilation creates two similar figures and it's an enlargement, your K factor is going to be greater than 1. But in a reduction, the K factor is going to be less than 1. It's going to get smaller. So let's say I went from this figure here to this figure here. I'll call this A, and then this A prime. So my new figure has the apostrophe on it, and I'll say this is B, then this is B prime, this is C prime. Okay, if I say that this is 3 and this is 1, and I say that this is 4, this is 12, and this is, we'll say this is a 5, and then this is 15. Okay, I want to know the scale factor. Well, remember I got smaller, so I'm going to put the new over the old, and so I'm going to just pick one. Well, I could do 1 over 3, that reduces, but I have to check every single side. So 4 over 12 reduces to 1/3, 5 over 15 reduces to 1/3. So if all three sides have the same scale factor, then it is the same. Okay. We can use the scale factor to you can find lengths of missing sides if two figures are similar. Okay, and the symbol for similar is that little squiggly line. So let's say I have, let's do this shape right here. And if I say, well, first of all, how do you determine that something is similar? We have 3 theorems, or 3 theorems. Okay, so SSS, which that shows you all 3 sides. Okay, so SSS, my example for that one is this one up here. All 3 sides have the same scale factor. Or SAS, and I'll do one like this. I'll say that these two are the same, and I'll say that, let's see, this is 3 and this is 6, and this is 5 and this is 10. And then if I know that this one is, we'll say 6, if I know that that side is, well, that can't be 6. Let's say it's 4. 3, 4, 5. Let's say it's 4. Then I want to find out this missing one. Well, you might be able to see the scale factor already. And I'll call this A, B, C, and this is A prime, B prime, C prime. Well, if I want to know, okay, this is the new figure, this is the old figure, or the original figure. And one thing that's kind of nice is old and original both begin with a 0, so it's a good way to remember the original figure or the old figure. So if you do new over old, so I want to set up a ratio, new over old. Well, first of all, I have to prove that they're similar. And I can see that my new is 6 over 3. These sides right here line up. I can set them up and make them the same color. These sides right here are the same. 6 over 3 reduces to 2. 10 over 5 reduces to 2. So if I want to figure out this one, I'm going to do new over old, or 2 over 1, because a fraction 2 can be written as 2 over 1, or a whole number 2 can be written as a fraction 2 over 1. And then I want x over 4. And to do cross products is you're going to multiply the two sides that are across from each other. So x times 1 equals 2 times 4, or x equals 8. So the missing side is 8. Okay? And one more little topic for review is just filling in a proof. Again, I'm going to make up 2 triangles. A, B, C, A prime, B prime, C prime. So I want to know if these two proofs are the same. If these two triangles are similar. So a proof, you need to put usually 3 pieces of information that you can gather from that triangle, and then the reason you know about that. So I'm going to look at these pictures, and one thing I know about these 2 triangles is that B is both a right B and B prime are both right triangles. So I can say that angle B is congruent to angle B prime, because that's given. Okay, that's given. The other thing I can say is that angle A is congruent to angle A prime, because that's also given. And I know it's given because the markings exist already. I didn't have to draw them in myself. They were pre-printed for me. Okay, so I could say given. And then I would need a third piece of evidence, because either you're looking for 3 sides, 2 sides and the angle between them, or there is the one special case that if you know only 2 angles are congruent, then you have enough information to say those triangles are similar. So that piece of information, this one was not needed. So I can say here that triangle ABC is similar to triangle A prime, B prime, C prime. And why is that? Because AA similarity. You probably want to see what I wrote. Because of AA similarity. Okay, let me make up another one. And let me go like this. 6, 12. And how about something like this? Okay, now let's look at my piece of information. What is it that I can gather from this triangle? What is already written in that triangle for me? Well, I'll call this X, Y, Z, and this I'll call A, B, C. Okay, 2 different triangles. Are they similar? Well, one thing I do notice is that angle X is congruent to angle A, and that is given to me. Okay, that's given to me, and I can see that because do you see how the little arc mark was already written there, and I just have to tell the world in my proof that they are similar. But what about this right here? I need to look at x, y, and compare that. I went from the top down, so here I'm going to do AB. xy equals 6 over 12, which reduces to 1/2. Well, how did I get that? Well, in a sense, it was given to me, but I also had to do a calculation. So I have to write that in there. And then let's look at xz and compare that to AC. And that is 12 over 24, which also reduces to 1/2. Well, do you see how I have the same scale factor? Okay, again, that was given to me because the pieces of information, the 12 and the 24, were there, but I had to do a calculation. Okay, and because the scale factors are there, I can prove that the triangles are similar. But which method did I use? Well, you see I have a side, I have an angle in orange, and then I have another side right here. So side, angle, side. It goes in order. So I'm going to do side, angle, side, similarity theorem. Oh no, actually that's going to be my reason. Sorry about that. I was like, what am I doing? Side, angle, side is my reason. And what is it that I proved? I proved that triangle XYZ was similar to triangle A. X is at the top, A is at the top. Y is down here in the corner, so I have to do it in the same order, A, B, C. So I just proved, okay, this is going to be your reason why they are similar. So ignore this little line right here. What did I prove? I proved that the two triangles were similar, and my reason is that side, angle, side similarity theorem. All right. Good luck on today's test. You should be, it's a very small quiz, 8 questions. You should do wonderful.